Welcome back to another week of the TapRooT podcast. This week we're going to be talking about troubleshooting like a boss. And as always, I bring in my two troubleshooting experts. I've got Justin Clark and Ken Reed with me here. So before we jump into the topic, I want to talk about why is troubleshooting important? Why do you need to be quick about this? What's the cost? What's the hurt if I'm not good about troubleshooting?
Yeah, great question. I can start. I caution on quick. It's got to be right. Is the way I look at troubleshooting. You can troubleshoot really fast and then do it 6 times if you don't do it right. So you always got to balance that out. Whenever you do troubleshooting of any piece of equipment, this could be electronic, mechanical kind of stuff. There's an entire process that maybe you're troubleshooting. Whenever you're doing troubleshooting, you have to have a plan in place, and the reason you're doing it is to get your equipment up and running. I mean, that's always your goal, is to have everything up and running. So you have to kind of balance out getting up and running like now, as opposed to getting it fixed right the first time and then having to have it down again tomorrow. So that's kind of the thought process in your head.
Yeah, and I think there's a good difference there between getting it just functional, right? We can limp along versus actually, is it truly repaired?
Right.
So I do think there is kind of a difference. And I know from my experience, I was never the troubleshooter. I was the boss on the other side going, how long is this going to take? Right? So there's definitely a pressure. Why is that? Why do people have that pressure? What's the problem with, why is there a time pressure for getting equipment taken care of so quickly?
Yeah, because revenue drives everything. We have to get our uptime because that is the lifeblood of our company. If we don't have this equipment up and running, producing product, making oil, making electricity, making cars, then it's a bad day. And that's a lot of dollars really quickly. And so a lot of times we mess ourselves into this thought that just keeping the equipment running is our job. And that's nice if you can get it back and running again, that, we're doing CPR on the production process. But if it goes down again for the same reason, that's that many more hours you lose. And so it is always worth it to take the extra time and prove how it failed rather than making a best guess and hoping that you fix the problem.
There is a little bit of thought process there too to kind of balance that out a little bit with what you had mentioned earlier. Is sometimes you do just need to get it up and run now. I need to get it moving now, right? Because of the revenue, or it's a safety issue. Justin and I are coming from the nuclear Navy side, so sometimes you just got to get the equipment back up and running like now.
The water flowing.
You're in the water.
Getting to the surface is a lot more important than the equipment staying online forever.
Yeah. If it's only up for 10 minutes, I'm okay with that. That's all I need. But so to do that, sometimes you would have to give the commanding officer some options and say, hey, sir, I can get this up right now, but here's your limitations. I'm going to have reduced power or reduced reliability. Or if you don't want to take that if you don't want to accept that risk, well, then I have to do this instead. But it's going to now require this much troubleshooting and this much repair. So you always have to give the plant manager or whoever the options and make them understand the risks or the benefits of doing that.
Now, I do think this is an interesting difference and we didn't intentionally side the table this way, but there's a difference. For you guys, your first fear is, I'm trapped underwater, got to get to the surface, life or death there. For mine, it was very much, you think of like, a lot of maintenance groups are measured by OEE, operational efficiency. They look at mean time to repair, mean time between failure. They're measured on how quickly they can get equipment back operational. And part of that, I think, of getting the speed side of it is that troubleshooting process and understanding what's broke quickly. So I think the urgency is there, whether it's life or death, or if it's maybe, our performance metrics that we're measured by. In order to be quick, you have to have a plan.
Right.
And so I think it's good to have a conversation here and talk about how do we get a plan, what helps us develop a plan, and kind of go through some steps. So how do you have a good plan for troubleshooting? What does that start with?
Yeah, well, I find the first thing is I guess I would say practice it ahead of time or think about it ahead of time, and not just be random. Oh, something's broke. Let's just run out and do something. You should have every time you're going to do a troubleshooting operation, there should be a generic plan in place of how you're going to do it every time, so that you're not trying to figure out, oh heck, I don't have any technical diagrams of this thing anywhere. I wonder where those are. You should know where those are, so when you have to troubleshoot, they're available. And oh, I need to be able to shut the power off to that. Oh, does anybody know where the breakers are for that? Or it should be something. I don't want to say practice. I'm going back Navy experience. We practice this stuff, but even outside of military experience, there should be something that you've thought of ahead of time, and not just say, oh, it's broke, send some guys out there, let me know when it's fixed.
So if we think of like medical, they have a crash cart. If there's a patient in trouble, they've got a crash cart. That way we can respond. What on a maintenance side is the equivalent to a crash cart? What are some things that they should have prepared before going out to do, I won't call them investigations, but to do troubleshooting response?
Yeah, and that's going to be, a lot of that is going to be the plan that we just talked about, having that beforehand. You're not generally going to run across anything new out in the field, especially if it's not some kind of crazy custom piece of equipment. Your engineers, your operators, your maintainers have probably seen most of what there is to see, especially if you have a lot of this type of equipment. No refinery operational team is going to run into a new pump failure mode. They're just not. We've been operating pumps, hundreds of thousands, for many, over 100 years now. We know all the different ways that pumps can fail. So having that plan of what do we need to look for when these things happen. And then from that, we need to go prove pipe strain caused this, or we need to go prove net positive suction head was an issue. Knowing all of those possible causes for a failure prompts us to create that crash bag, so that, I have my pump troubleshooting that I need to do. I have my pump troubleshooting kit, whatever that might have in it. It's probably going to have things like, maybe a pressure gauge that you hook up to a connection point in the system. Maybe there's going to be, an infrared thermometer so you can look at bearing temperatures or piping temperatures. Maybe some kind of knife to cut insulation off of piping so we can see what is the corrosion going on near, a hot.
So I think of my experience, the big tooling carts, our little maintenance guys pushed around, big giant things. You're kind of mentioning there's unique, right? Every facility has its own equipment, its own problem children, if you will, for equipment, right? There's different things and processes you may need. So I think that first planning step is to recognize what's unique about your facility then, and say, okay, what are the types of troubleshooting that we're going to be doing? That's what you were saying. And what types of equipment or things do I need when I was maintenance, we had our maintenance group that was the secret behind the curtain thing that you'd go back and they had all their little toys and stuff, and then they'd come out with their carts. So I think having something organized so that they know what they're going to need to respond, whether it's to certain equipment or certain areas, any way you can speed up that, get them to the site faster, I think that helps.
We had different divisions, is what I was used to, where you'd have the mechanics would have their types of equipment that they need, and then we had the electricians who had their electrical troubleshooting type stuff, and then my division was the electronic control system. So we all had very different sets of equipment, but I never troubleshot a pump. I would troubleshoot electronic controls. So I had specialized equipment that I could go grab very quickly, and we practiced on it. I didn't practice on pressure gauges for pumps and those kinds of things. I practiced on TDRs and things that we would use for troubleshooting electronic equipment.
Now, were those shared carts, or was that your own?
It was pretty much our own. I think each group had our own. I don't know if I'd call it a cart. It's hard to roll around a submarine, but a locker. We had our equipment troubleshooting locker where all our equipment was at, and each of us had our own sets of equipment.
And that would be shared across shifts. Locker.
Oh yeah.
So something else that I've noticed when you look at like shared assets, having a real clear, we would call it 5S in manufacturing, which is like, this is the way it's laid out so that everyone knows the same layout. Because otherwise you get, well, I keep this here and this one's in this drawer and somebody's just scattered looking around. So having it well laid out, well organized, I think all of those kind of things help set people up.
So you go to an auto mechanic and he's got his tools, right? Each mechanic has their own set because they want their 5S system set up exactly like they like them. That works for a mechanic like that. But if you have people are going to work cross shifts, it's actually a little bit more difficult to maintain everything where you want it, where it's supposed to be, and that all changes your speed. I can't tell you how many times when I can't find at home, I can't find a wrench or whatever it is I'm looking for because I know my kid had it and he didn't put it away. I mean, that slows you down, right? You're saying, all I need to do is take this nut off and I can't find my 9/16 wrench. Who has my wrench?
Yeah, that was the dad's toolbox drawer, and you're like, nope.
Yep.
Just keep searching through until you found the one.
But boy, that slows you down if you don't have everything organized properly. So that's the first thing, is have your tools organized and your troubleshooting equipment ready to go. I think another thing that we had mentioned earlier is also your troubleshooting plan. And while we said practice that, what does that look like? And I know in the back of the TapRooT book we have a troubleshooting sheet that we've got that kind of steps you through symptom recognition and elaborate what does that mean when you have a problem there, and then troubleshoot each of those pieces. So
that's the 7-step troubleshooting process.
That's our 7-step troubleshooting process that we have built into the, I can't remember which appendix it is in the back of the Equifactor book, but it's one of the last appendices back there. And that was actually developed from my experience in the Navy, is where that came from. It's what we used. First thing you did when something went down, by the time I got back there as the leading chief, I get back there and my guys already had the sheet out there and they're working through it, starting to write down everything they can find. And the symptom recognition is the first thing. Sometimes you don't even realize what you're troubleshooting when you get back there. What was the problem that prompted you to go troubleshoot? What is it? And you lose sight of even that initial symptom sometime if you don't write it down. You got to write it down, and then you can work from there.
So having the right kit to start with, and then knowing your plan for how you're going to troubleshoot. What's the process for troubleshooting going to look like? So I think you started us into this 7-step discussion. That first is symptom recognition. Now, I think for people listening, there's going to be people here that are experts in equipment and non-experts. When we talk about symptoms for equipment, what are we talking about? What are we looking at here? You have this as a written down statement. What is a symptom in equipment failure?
Yeah, it could be. It's usually the thing that prompted you to start troubleshooting. So the pump shut off. That might be your symptom. It could be I had an alarm on the panel. This alarm came in, and it's usually it's kind of like with the rest of TapRooT, the worst symptom, right? What is the thing that prompted you to say I need to go fix this right now? And I try to, in that symptom recognition, just write down the first symptom that you saw. The next stage, you'll start elaborating on that, but your first symptom is, why am I doing this? And like I mentioned, it's amazing how many times you lose track of the reason we started troubleshooting here. You wouldn't think that would do it, but you start going off on these rabbit holes or these other different directions to go, and you forget the reason you're here is because this alarm went off. So you've got to recognize that first.
Yeah. As humans, we are really, really good at focusing in on one thing at a time. And if we have this, my check engine light came on. Okay. And then I go start to troubleshoot. That's the thing that caused me to start looking at stuff. Okay, I put my OBD meter in and look at all these codes, and 30 of them pop up at once. If I just start going in one and one and one and one and one, I'm going to be led in a zillion different directions, whereas keeping that overall, first symptom recognition, and then the next step is symptom elaboration, going into, okay, all of these things are happening. I have all these alarms going off on my propulsion plant or my electric plant. I have all of these different codes going off for, I drive a Mini Cooper, all these things going off for the different modules of the electronic system. If I get really narrowed in on any single one of these, I'm probably just going to find it's not spurious, but it's just a kind of a sub thing going on. It's another result. That first thing that happened is really what we need to stay focused on.
And we go with, again, we love our car analogies here. So kind of that focusing on a symptom. If I'm hearing a knocking noise, if I'm hearing a noise from my engine and I'm trying to troubleshoot that, and I plug in and I get 30 things, and I've got a bunch of stuff about some sensor that has nothing to do with, this noise.
The sunroof issues, yeah.
So it's like, I'm getting some code back. Well, I don't need a foot. That's a problem, but that's not today's problem, perhaps. And so I think by having that clear recognition of what your symptom is, it helps focus you in on what are these things I'm really needing to get information for.
That's right. That's right.
Okay. So we've got the symptom recognition. I take it back to my experience. This would be maybe I've got some sort of quality issue that I'm recognizing as manufacturing. I might recognize there's a quality defect, and I've done my stuff to troubleshoot from an operator standpoint what we have. So now we've called out maintenance to deal with this. What is that second step? You called it symptom elaboration. What are we talking about there?
Yeah, so getting an idea of really everything that could be causing that symptom, but just making sure that we understand not just that first symptom, but everything else that's going on, because there can be a lot of commonalities that we wouldn't notice if we put these three things are happening together. That can really drive us towards, okay, there's probably not 4 concurrent failures that happened all at once, especially in an electronic system. There's usually just one, maybe a pre-existing one, and then your current one. But looking at all of those symptoms together can give you a good idea of the smallest number of things that we need to look at to find that explains all of them. Because this really helps us to narrow down exactly what we're looking for and keep the timeline for proving what happened a lot shorter. Because if we just look at every single one of those and look at, okay, when I have this fault, it has these 10 things. And then I have this fault, it has these other 15 things. But if I don't start to build all those together and overlap them, I have to go read all the tech manuals everywhere. But if I can start to see, okay, these 2 things are starting to line up here across all these different issues. My test points keep telling me these things. Okay, now we're starting to move towards figuring out what's actually going on.
For example, in a seawater system or a cooling system, you might have your initial symptom recognition is I had a high temperature alarm on the outlet. But your symptom elaboration would be, well, I had a high temperature alarm, but I also noticed that my differential pressure is lower than it's supposed to be across the pump. And I also know that my inlet temperature is actually higher than average today. So I'm going to write that down as an elaboration of my symptoms. So that makes sense. That's in there. And maybe I'll also in my symptom elaboration might be we're using the system differently today than we normally do. Maybe we normally run 2 pumps, but today, because they're doing maintenance on the other pump, I was only running 1 pump. Oh, okay, let me write that. Only single pump operation today. So these would be additional symptoms that you're putting in there that while they didn't trigger me to do the troubleshooting, there are additional pieces of data now that are going to start, before I even start really troubleshooting, before I'm actually tearing things apart and looking at things, these are the noticeable, the visual, audible things that I've got going on that I now will help me narrow down where I need to go.
So it's helping you better look for additional pieces of information that will give you more context to this symptom,
That's
the
right.
original symptom.
And the problem here I see a lot of times at this point is that an expert will say, oh, I know what this is. We had a low pressure on the pump. I know what does that. And they'll go down that rabbit hole. And it might be right, but if they're not pulling the other symptoms together because they don't write them down, they end up missing the opportunities to narrow down the actual problem because they're so sure they know what this is.
Now, is this required because of the complexity that often comes out of maintenance systems? That there can be maybe not always, but there definitely can be times where there's multiple things that are affecting that are resulting in some type of symptoms. It's not. Sometimes it's single.
Sometimes
the component failed, caused the issue.
Yep.
But a lot of times there's also these elements of, it's. I hate to think of the word off the top of my head, but it was like emergent. There's an emergent symptom, right? It emerges from complexity. So is that something that this elaboration can help you kind of uncover a little bit of the connection points?
Yeah. I don't know if I call it complexity necessarily. It could be, but it's more system interoperability, how all these different systems affect each other. So if I'm doing something over here, I need to know how that's going to affect this piece of the system over here. And by doing the symptom elaboration, it helps you narrow down and identify where these interrelationships in the systems are between your electrical systems, and maybe I had a brownout or something in power. I had low voltage in my system for some reason, and I need to understand what that does to the rest of my plant when that happens. So yeah, whether we use the word complexity or interrelation, or it's all built into that. Yes.
Okay. Now, we take elaboration. We kind of have an understanding of the symptom. What's the next breakdown that we need to help us continue the troubleshooting process? It's looking for, I know in the steps it's looking for faulty functions, but what does that really entail? What's that mean?
Yeah, so if I have a pump that's required to take a low pressure feed and turn it into high pressure, there's only so many things that can go wrong in that pump between low pressure and high pressure, and if I'm not getting high enough pressure on the back end or high enough flow on the back end, that will really help us to localize. Okay, we've gotten the problem down to this bit. What could possibly be between this flange and this flange that is causing the issue? And
this is almost exactly what we were talking about, the interrelationship between the systems. So which system are we looking at now? And that's the faulty functions, faulty system. Which system are we trying to troubleshoot here? Is it really the pump, or is it our electrical power supply? Is that what we're doing here? So when we're doing that symptom elaboration to identify possible faulty functions, this is where we start narrowing down those faulty functions, these faulty systems.
So we went wide first just to catch.
Yep.
And now we go, okay, we start to see these things. This says we need to be focusing on this. Again, I take it back to mine. It was like, okay, we've got vibration. Okay, there's only a couple things that could be causing vibration. So we're going to look at those 3-4 things that could be causing that.
Because some of those are results. Some of those faulty functions you see are results of the first problem. So if I have low voltage on my system, well, I'm not going to troubleshoot the pump. I want to troubleshoot the power system, because that would have affected everything else here. So sometimes that localizing the faulty function is identifying the one or two things that is globally would cause the rest of these symptoms. So it's kind of a logic problem that you're working through here.
Now, and you said localizing that. So this might be a larger process, and you mentioned localizing it. What do you mean by localizing? What are we looking for?
Well, think of a string of Christmas lights. Some of the older ones are, they did, but if you have one bulb burn out in that whole thing, then you have no idea which bulb it is, and you can either go one by one and look at all the bulbs to see, or you can start doing another one of these troubleshooting tactics that we call half splitting. There's many different ways that you can jump into troubleshooting if you do know what a smoking gun is. That if you get to symptom elaboration, it's like, okay, low voltage is the only thing that could be causing all these. Let's go fix our voltage problem, sure. But then, at a certain point, you do need to, if you have a really complex system, there's many different parts, and you just have one failure that you need to figure out where it is, you need to start being a little bit more logical with it and having a plan to prove, eliminate what we don't care about, just like we do in the rest of TapRooT. The best thing we could do is eliminate where the problem is not.
So we've got a long string of Christmas lights. Now, there are different ways I could approach swapping those bulbs. What are the different ways I could approach this? At least the more common ones. What are some common ways?
Unfortunately, one of the most common ways is Easter egging, where you just kind of say, I think maybe that one. Let's try that one.
So I can imagine I'm sitting there, with
150 bulbs.
150 bulbs, and I go, I feel like it's this one, and I just pick it. That's the hope you got the right one.
Maybe you saw a little discoloration on it, and you said, I wonder I think that's it. I think that one, yeah.
I feel them. Does this one feel warmer?
And Validity given. If you do have reason to believe, you know exactly where it is. In a Christmas light situation where...
You know what? Okay.
You know what? I knew that one was, starting to go.
It stopped. Somebody stepped on it and broke it, right? I think that's the one right there, right? Okay.
There you go, yeah.
I'm okay with that. That's
Yep.
okay.
So Easter egg, that would be, it's not random necessarily, but educated guessing at which one to pick.
That's right.
We'll put it
Yep.
the best case. What's another method I could go through to find it,
Yep.
find that Christmas light?
So the next one usually is what a lot of people's brains work on really well is a linear type process where you just say, all right, I'm going to try, I've got 8 different things to try. I think I'll try this one. Nope, that didn't work. Let me try this one. Nope, still didn't work. I'll do this one. And you just work straight down a linear path.
I've done that with Christmas lights.
Yep, and that can work.
Swap bulb, swap bulb, swap
Yep.
bulb.
That can work depending on the type of that. None of these are wrong, by the way. You have to decide which of these methods we're talking about works the best. Easter egging is probably the least likely to be the correct one, unless you have a really good indication.
Mm-hmm.
Linear can work very well. It's very structured. It's how our brains work. We work in straight, one by one by one, and you don't miss anything because you're going down through.
If my string of lights is only 20 bulbs long, I don't need to do anything complex. Just
That's
okay,
right.
there it is.
It might make perfect sense to do linear. It's very functional. It works well. The disadvantage is when you have a large number of checks to do. If the problem is down here somewhere, unfortunately, it takes you a long time to get there. So that's the disadvantage of that. It can take longer to narrow down. Yep.
Now, if I've got a larger system, maybe less. It's not 20 lights. It's 250,000 lights.
Mm-hmm.
Now we're talking big. What is some other methods that I can use then to narrow that in maybe a faster way?
Right.
Yep, and this is the one that I mentioned, half splitting.
Mm-hmm.
Getting rid of everything that doesn't apply or that we don't care about. If we can, prove that this portion of the system is good, then we can start narrowing down very, very quickly.
So you go right to the logical center of the system. You say, well, let me test it here. Oh, I get a good reading right here. That means everything up here is good. All right, it must be down here somewhere. Let me check in here and let me go to the middle again and say, oh, I didn't get a good reading at this point. It must be between here and here then.
Yeah, I think that's like your voltage checking, right? Yep, I'm getting connection between here.
This is probably more likely to be used in electronic and electrical troubleshooting. This type of half splitting is probably more appropriate for those kinds. It's not like a valve troubleshooting, where I have to figure out which valve isn't open. I mean, you can use half splitting for that, but you probably don't have 5,000 different options there, right? There's only a few. But when you have a lot of options, that's when the half splitting fits.
Well, even fairly simple systems it's really, really helpful too. Back when I was living in Florida, I had a robot lawnmower because nobody wants to mow their lawn in the middle of the day in Florida summer. But it needs to get mowed about 3 or 4 times a week to keep it nice and good. Well, my robot lawnmower has a boundary wire. And all of a sudden, robot won't start because boundary wire doesn't have any voltage. Okay, where's all this going to happen? Instead of walking around all this different crazy wire that's under grass and all this dirt is over it, grass is over it, and having to walk down where all these things are, I just bought a whole bunch of little test point fittings. I go to where I think the half point of the system, cut the wire, put them both in there, and now I have a test point built into my system. And so now I can test voltage between base and halfway point and say, okay, that side of the system's good. That side of the system's bad. And I did that maybe 2 or 3 times. It's maybe 1,000 feet of wire. But then rather than, again, having to go out in hot Florida sun in a hazardous condition, you're able to do these things really quickly and narrow down, okay, I know it has to be around this little portion. If I do need to do some digging, sure, but then very, very simple home system that saved me a lot of time in walking down and digging, and I did eventually find the thing because I was able to, it is in this 15-foot section. And then that allowed me to prove that's exactly what went on, replace that little bit, put in another test point right there because the wire's already broken. I think something had chewed through it at that point. But
Get the moles down there.
The moles.
Yes.
yep. So even pretty simple systems, it helps a lot. But then, let's say I have a fire suppression system on an oil rig with 4 floors and thousands of old style pneumatic valves, and I have a pinhole leak there that I need to fix. This is an emergency system that needs to work. We failed our test because of the pinhole leak. Okay, where is this leak in all these miles and miles of piping? I would not even be able to see it if I were looking at it sometimes. So, split it in half. Decks 1 and 2, split them from decks 3 and 4, and
See
now
where
okay,
the pressure goes away.
Yep.
Right? Yep.
which one is it? And this brings up another good point. Some of these tests are not just looking at it. Okay, this light bulb has failed. Some of them take 24 hours to operationally properly prove that it works. I need to do a 24-hour pressure drop test on these 2 decks. That takes a lot of time.
Space Station did that just last year. They're trying to figure out where they've got a small pinhole leak, air leak on the system, and they shut some hatches. They shut a hatch and checked which side of the hatch the pressure went away on. And now this took over several days because, if I remember right, it's a tiny leak with a lot of volume. So you're trying to, and you got to take into account temperature changes and all the other stuff are in there, right? So, but they shut a hatch, they half split, said, all right, which side of the hatch do I have the leak on? So it's well used in many different situations where there's really no other way to do it sometimes.
Now this reminds me of, and I don't know if you guys have ever gone down this rabbit hole, but I remember there's a YouTube video that shows different methods of sorting, and this was sorting just names alphabetically. And so you could just grab each one and put it in the number. You could sort them by splitting to, like, you'd pick a point in the alphabet and split. There were ones that you would do, is this one ahead or below the one previous?
Just swap
And
that
they look at
out.
all the different speeds at which you could sort things.
Yeah.
And so I think when we take this approach, there are a lot of different ways that you could do sorting to find where that problem may be at. This is kind of that planning thing, knowing what types of systems, what sorting works best in. That's almost could be really tricky when you're thinking of, like, if I was trying to implement this in a new place that isn't familiar with these. So that might be where somebody might need a little additional counseling on is what type of localizing process works best for what type of system.
And sometimes the halfway point is really hard to do. Maybe it's hard to shut this valve because it supplies air pressure over here, so I don't want to shut this valve. But if I shut this one over here, it's not really halfway, but it's much easier and less affecting of my system. So I'm going to do this one. So understanding the ease and the results or the consequences of doing your half splitting can also determine where the best place to do your troubleshooting is. So lots of different things to think about. This isn't as black and white as a light string, and we're going to sky one half or the other. That's the simplistic one.
So the next kind of phase as we're narrowing down is to find, localize the component that's failed. In case in troubleshooting, we're typically looking for a component failure. Does this process, is this kind of where Equifactor would help people in this process of they have that symptom identification and they can find these possible failure modes? How does Equifactor fit into this troubleshooting steps in here? Where do those two come together?
Yeah, a lot of those. So the Equifactor portion is going to be kind of all that pre-gaming. If we see this symptom, here's the things we need to go look for. And when we see, okay, high bearing temperatures, what are all the things we need to check? And that's going to give us our low-hanging fruit. Go check your strainers. Do you have babbitt in the strainer, or do you have a whole bunch of sand or grit in the strainer? Do we have somebody working on the steam side and they had to, I don't know, they're getting really hot, they took off their shirt and it got sucked into piping somehow. I don't know, these things. We find a lot more clothing in the sewage pumps on submarines than you would think. But that's gonna say, here's the steps, how easy it is to troubleshoot it. Before we tear this pump out of the system, let's check these things first, because if we do find, okay, yeah, somebody did, dump a whole bunch of sugar in the engine of my car, I'm not, I know what happened,
Right.
or
It's kind of used in almost all of these sections we just talked about. Symptom elaboration. You can use Equifactor tables to figure out which of those symptoms you want to look at. Symptom localizing the faulty function. All right, so here's those symptoms. We can go look at Equifactor and say which ones are hard to do, which ones are easy to do. Let's do this one first. And then same with the component. It's kind of just the next stage down is your troubleshooting. So it can be used in any of those 3 stages we just talked about.
And I think that's important for to understand is, an Equifactor table is built of what is the equipment, component, valve, whatever it is. So you have your starting point is what is the equipment you're troubleshooting. Next you have a list of symptoms that say these are the possible symptoms that are causing you problems. And then you have under each symptom is a unique list of possible causes.
Right.
Now, I was having this discussion with Marcus the other day that those lists, sometimes people say, oh, that's the list of root causes. And you're like, no, those aren't root causes. All those are a list of, it's the physical or equipment cause. It's the list of equipment causes.
I call them the physical causes.
Yeah,
physical cause of the equipment failure.
Yep,
Right?
yep. So they're the equipment failure causes, which is, it's really a causal factor list in a lot of ways. It's it's an equipment causal factor list in a good percent. Not always, but a lot of times it may go one level deeper for what caused the actual or what was the causal factor under that equipment failure, but it's a good physical equipment failure list.
Yeah.
So they could use these tables. We have the symptom, look it up. Here's our symptom. Is there anything else we could help elaborate? Any other symptoms we're seeing?
That's right.
And they can go down and say, hey, here's the list of causes that we can then make our localizing plan for. Here's these possible, we can order them out and make
That's
our
right.
plan.
That's right.
So that's kind of where that helps us identify component failure. They can do it the linear splitting, half splitting methods, or Easter egg just gas inject.
If you want to.
Or we can give a little bit of a plan that helps them organize that with Equifactor. Once you've found that component, we want to make sure we got it right. How do we do that when it comes to equipment failure? What is it that we need to be able to do?
Yeah, you kind of want to look at what you found and ask yourself, will that cause the stuff we just saw up here? You want to kind of look at it and say, okay, I found a bad lubricant in the bearing. I found we used the wrong oil here. Is that going to cause everything we just saw up here at the top, the symptom recognition, symptom elaboration, all those symptoms we saw? Somehow we need to say, yeah, this thing we just found does that. Because sometimes you find something and it doesn't really fix everything. It's like, well, what about this thing over here? And you find out that that's actually another problem over there that you need to go take a look at. So what you're doing is proving to yourself, yep, what I just found, yes, that is what caused what I was just that got me into this troubleshooting in the first place. So it's an important step to make sure that you're not picking something that's another symptom is what you end up doing. So it's pretty powerful.
Yeah, if I find, okay, I'm losing all this flow, or I have this high noise for my pump, and I see, okay, my impeller is chewed up. My impeller has been completely destroyed. Okay. We don't just replace the impeller. We found the physical cause of failure. We found, this is what's causing the high noise. This is the big thing that was going on. But at a very simple level, that does not explain, okay, how did our impeller get chewed up? Is that a corrosion issue? Did a valve stem break off upstream and go in there and get kicked around, actually throwing a wrench in the engine?
Drive cavitation in the pump or something, right? All these things. Yep.
And that'll expand the scope of my investigation, because now, okay, I have found what caused my pump to fail. But now I have a separate troubleshooting sequence that I need to go through. How many valves do I have in this plant? Where did this valve stem come from? And eventually you're going to have to work, and this one is only upstream that this valve could have come from. Go check my strainer baskets. If my strainer basket is in place, then it had to have come from downstream of that strainer basket. So I go look at the valves there.
I think this step is where a lot of this proving to yourself that what you're fixing is the actual cause is the bottom line. I think this is where most companies fall down. They oftentimes find, bad impeller, and corrective action, put a new impeller in place. It's like, yeah, but it didn't come bad. The impeller was good yesterday or last week or last year when we put the pump in. Why is the impeller bad? What caused this big hunk of metal to get all chewed up like this? And just throwing a new impeller in is not doing this check of the faulty component and asking yourself, am I satisfied that what I just found here caused all this stuff up here?
So I think, one, this is a good case for when people should maybe consider doing a deeper root cause analysis investigation. The other thing I think about this is, from a quality perspective, because all these techniques we talked about from troubleshooting is maintenance, but quality perspective, one of the things I learned is you should be able to test it. You should be able to turn it on and off. At this point, if you know what it is, you should be able to turn it on and off from a quality system perspective or a maintenance perspective.
Turn the symptoms on and off.
Yes, exactly.
The problems on and off.
So I should be able to create or not create that. If I actually have that cause found, it should be able to, if I could turn it on and off. So
it's ideal if you can physically do that. Sometimes you got to do that mentally.
Yeah,
right?
Exactly.
Right?
So there's some of them it's like I can just replace it and does the flow work. Yes, it does.
Yay.
And so there's other ones where it's like, okay, I'm swapping out the light bulb. Well, if I take this light bulb out, the lights don't work. If I put it in, the lights work, right? There's some of those kind of things where you can just swap it.
That's cool when you can do that.
But other times it's like, okay, does this logically make sense this could be leading to? So yeah, there's definitely a level of validation. Might be, pure turn it on or off, or it's, yes, this makes sense as it would cause it.
Yep.
Last step in this, I know what I need to fix. Last step is super easy, right?
Fix it.
Fix it. It's the easiest. Just easy. You just fix it.
Yeah.
I think there's obviously a lot of things that can come over time with learning to repair and speed. But if you found something, this is kind of your point, you found a defect, well, that defect might have been put in place by the repair process. So making sure that the actual repair process is appropriate and not recreating the same defect that you found.
That's right.
Can also be things to look for. Now, we've covered the 7-step process for troubleshooting. Now everybody can troubleshoot like a boss.
Yeah.
But let's say they want to learn more about any of these aspects in troubleshooting, Equifactor, things like that. What are some resources that they should look at?
Yeah. So we've been writing blogs for a long, long time. That's the first place and easiest place to go is go check out the blog, click on topics, scroll down to equipment reliability, maintenance, troubleshooting, and that's going to pop up all those wonderful nuggets that we've developed.
They can sign up for the Equifactor newsletter. So that's an easy way to get locked into the Equifactor newsletter. If they want to go more and learn more, what's the best resource for them to actually get the training they need on this?
Yep, there we go. And that's the next step. Once you know that's Equifactor, you need to go learn it. We have an Equifactor course. We teach virtual courses. We teach in-person courses, usually attached to a TapRooT course, so that after you prove how the equipment fails, you can go do the root cause analysis and find those things.
So they can reach out to us on our website at TapRooT.com. They can find a link to go get more information, or we've got, upcoming public courses for Equifactor at our TapRooT Summit, so they can look for that, the TapRooT Summit, if they want to learn more about that, and also, enjoy the equipment troubleshooting track, which I know we also have. So anybody that wants to learn more about these and a lot of other cool equipment trouble things, best places to go to our website, taproot.com. The link is down below. You can sign up for the newsletter, the Equifactor newsletter. You can check out information about the TapRooT Summit and upcoming public courses, or you can message us directly for information about Equifactor. Justin, Ken, myself, or any of our other people in the instructor side will be happy to talk with you about it. So
absolutely.
You can also check out the TapRooT Book 5, which is the Equifactor book. It includes Equifactor troubleshooting tables. Reach out to us. Again, links are all down below. As always, subscribe, hit the notification bell if you want more information on this, and see more great podcasts. Hope to see you again in the future episode.